Hi guys, and welcome to Chapter 12. Chapter 12 is going to be going over freshwater, oceans, and coasts. It's also going to be looking at water uses, water pollution, and some of the issues associated with ocean ecosystems such as overfishing. But for the first lecture, we're just going to be talking about freshwater. Now, freshwater is water that is basically pure. It doesn't have very many dissolved minerals, so not a lot of salts, not a lot of metal ions, and it's actually pretty uncommon within the aspect of the Earth. Only about 2.5% of all water on the Earth is considered fresh, and out of that 2.5%, most of it's in the polar ice caps and glaciers, so most of it is completely inaccessible. It is basically solid water. Only about 1 part per 10,000, or about 0.01%, is readily available for human use. So it actually really should be underscored here that we don't really have a lot of readily accessible fresh water available for drinking use or for use for industrial and agricultural applications. And that should be really noted because we are essentially running out of some of the available fresh water that we do have, something that we'll be talking about here in just a little. Now, fresh water can be divided broadly into surface water, which is water located on the Earth's surface, and that's going to be things such as what you're going to find in lakes, rivers, and ponds, and then groundwater. And groundwater is going to be water beneath the Earth's surface. And this is going to be stored in something called subterranean aquifers. We've touched on groundwater in a lot of the different chapters in this course so far, but we're actually going to go into what groundwater is and why it is important, because we get a lot of our drinking water from groundwater, especially in Florida. So basically, there are porous formations in rock and soil, basically underwater little porous spaces, which are usually found in limestone. So it's good. We're going to have a lot of aquifers or pore spaces in Florida in particular, and they basically hold water. Basically, the water table specifically is going to be the level below the ground in which the ground is completely saturated with water. So you can almost think of the ground as a cup or a container, and how high up the water is in that container relative to the rest of the ground that doesn't actually contain any water is going to be your water table. And you can see that below in the conceptual diagram of an aquifer on the bottom right hand side of your screen. Now, typically when we think of an aquifer, we like to think of what is called the unconfined and the confined aquifer. Normally, there is going to be a layer of clay, which is impermeable, that goes about halfway through the aquifer and kind of bisects it into an upper and a lower portion. The unconfined aquifer is readily accessible for surface water. So surface water and your water table is going to elevate and diminish as drought conditions or as rainwater conditions apply. The unconfined aquifer is very susceptible to pollution in particular, because anything that is resting on top of the ground can essentially percolate down into the unconfined aquifer simply because of runoff, and anything that is soluble can kind of make its way into that. Contrast that then with what is called the confined aquifer. And the confined aquifer is actually underneath that layer of clay. Now, unlike the unconfined aquifer, the confined aquifer isn't really going to be terribly respondent to changes in the water table. Instead, there are going to be specific recharge points, basically where the clay membrane is no longer going to be there. And so those are the areas where water can actually get into the confined aquifer. The confined aquifer is typically going to be 600 feet below us, so it's going to be very, very deep. And it's typically where the majority of the state of Florida gets their drinking water. The sole exception actually is Bay County, ironically. Bay County is the only county in the state of Florida that relies on surface water, Deer Point Lake, up in the northeastern part of Bay County, as reliant on its water. Everywhere else in the state actually relies on either the confined aquifer or the unconfined sand and gravel aquifer in some of the barrier islands along the coast of Florida. So just to give you an idea of what the aquifer can look like, in most places the aquifer is pretty compact. The porous rock is pretty impermeable, and it's very hard for people to get in there and look at it. However, in other places, the Floridian aquifer can be incredibly visually arresting. Some enormous chambers have opened up as the water has continued to erode away some of that limestone, and it's a very popular destination for divers, particularly cave divers who are very interested in this kind of stuff. Now, cave diving is extremely dangerous. It takes a ton of certifications and training to be a competent cave diver, and as a result, a lot of untrained cave divers or amateurs who aren't really trained can typically get lost in these caves and actually die. However, in areas where you have a competent, experienced cave diver, some of the photos that they take are just absolutely incredible. There was a graduate student that I worked with when I was at the University of Florida named Jenny Adler, who actually did her PhD on the different aspects of the Floridian aquifer, and now she's actually a photographer for the National Geographic. Look up Jenny Adler if you have time. Her Instagram and her photos for National Geographic from her time doing cave diving is just incredible, and it gives you an amazing idea of what the Floridian aquifer looks like underwater. But going back to the diagram, if you look at the recharge area for the lower or the confined aquifer, you can see that it's normally in very mountainous regions or areas with high altitude where that clay impermeable membrane kind of is removed. And then you have different types of wells depending on how deep you want to go into the aquifer, and then a spring, which is a natural entrance into the confined aquifer, are a lot of entry points for some of these divers as well as popular parts of recreation. So just kind of study these different diagrams. They give you a really good idea of what groundwater looks like and what aquifers look like, and it gives you an idea of where your drinking water actually comes from. Well, maybe not your drinking water, but if you have lived in any other part of the state of Florida, where the drinking water for those people come from. But moving on, we're going to go into a few broad terms for freshwater. The first is a watershed or a drainage basin. Basically, this is an area on a ridge of land that separates flowing waters from different directions. So normally this is going to be in a place where elevation peaks. So whenever you have a mountain or a hill, anything on one side of the hill will go into one drainage basin, and then everything on the other side of the hill will flow in the opposite direction, just as a result of as the water moves through along with gravity. A floodplain is an area of low-lying or adjacent ground to a river. So it is an area which has exposed river sediments, and it's basically the upper boundary of where a river can flood to. So you can almost think of this as a tide plain for a river. When the river is seeing a lot of heavy rainfall, the waters will naturally rise up to the upper regions of that floodplain, and then which is called the flood stage. And then as the rainfall begins to die off, and there isn't quite as many heavy water inputs into a floodplain, the river naturally dies back down to its typical level. Anyway, and then finally, a term that you really need to know is something called runoff. Runoff is just water that is flowing along as a result of excess rainfall, snowmelt, or other precipitation sources flowing along its surface. Moving along, freshwater ecosystems have different zones. Fun fact, I've actually been working on a few freshwater ecosystems for the last couple of years over in Walton County, and so it's kind of neat to be able to talk about some of the aspects of the regions that we've been working on. Anyway, so the littoral zone is the nutrient-rich edge of a water body. This is normally going to be where you have a lot of plants and vegetation right along the edge of the water. Normally, this is going to be a very shallow area, and it's going to be areas where the sunlight can actually penetrate, and so that different aquatic vegetation and different aquatic plants can actually get enough sunlight to photosynthesize. Contrast that then with what's called the benthic zone. The benthic zone is the bottom of the water body, typically in the deeper stretches of the lake. This is normally an area where you don't really have a lot of sunlight. The lake normally, or the lake water, is a little bit brown or muddy, and maybe it kind of filters the sunlight before it reaches that area. As a result, the benthic zone probably doesn't have a lot of plant life or any life for that matter. Normally that area is pretty oxygen deficient, and it doesn't have a lot of life. Normally when you want to think of the life in a lake or a freshwater body, it's going to be in the littoral zone or in the limnic zone. The limnic zone is basically the open portion of a lake or pond where sunlight allows photosynthesis. It's very closely related to the littoral zone, and it's going to be the area where we see a lot of life. Normally there's going to be a lot of convection and a lot of current, so there's going to be a lot of mixing, and as a result these areas stay very well oxygenated and they stay very well lit with sunlight, and as a result you get a lot of life. This is where you're going to find a lot of plants. This is going to where you find a lot of fish for fishing, so it's popular for fishermen, and it's generally going to be the area in a lake that has the most biologic activity. Speaking of biological activity, there are also different classifications of freshwater ecosystems based on how much biologic activity they have and normally how many nutrients that ecosystem has. And this ranges from oligotrophic all the way up to eutrophic. Now, I want to make a point here to have you distance the idea of eutrophication, which is the artificial increase in nutrients in a system, versus a eutrophic lake. A eutrophic lake doesn't necessarily have to be polluted. Sometimes water bodies are naturally exposed to high nutrients, particularly if there's a phosphorus or a nitrogen deposit nearby. They can already have a lot of nutrients in that system, and it doesn't necessarily have to be involved with pollution or fertilizer inputs into those water bodies. There is a difference between artificial or anthropogenic or human-induced eutrophication and just a natural eutrophic lake. Now, going into this, we're going to start with the nutrient poor or oligotrophic lakes. Oligotrophic lakes are normally going to be those that are very clear. They have very low nutrients in those ecosystems and very, very high amounts of dissolved oxygen. So you're going to have typically not a lot of biological activity. There's not a lot of food for plants to actually grow, and as a result, there's not a lot of food to support higher levels of that food chain. So you're going to have very clear systems, very high levels of oxygen, and typically lower levels of biological activity. Then moving forward, you have what's called your mesotrophic systems. Meso just means middle, and so you're going to have in-between conditions between moderate levels of nutrients and moderate levels of dissolved oxygen. These lakes are going to be a little bit shallower. Basically, sediments have kind of come in and filled in. You're going to have more phosphorus and more nitrogen, so more food for plants. As a result, you're going to have more biological activity, and it's going to support more levels of life. Note that mesotrophic systems are important as a learning tool. It's nice to know that there is a continuum between oligotrophic systems and eutrophic systems. However, mesotrophic systems are not actually required for this class. I just think it's an important learning tool to keep in mind. Then you're going to have those eutrophic lakes that I was just talking about. These are going to be high nutrient ecosystems that have low amounts of dissolved oxygen. They're typically pretty shallow, and they have very high amounts of biological activity. Remember that sometimes a eutrophic lake is just naturally high in nutrients. It doesn't necessarily have to be associated with human-induced pollution as a result of fertilizers coming into the water body. However, the trend of oligotrophic lakes to rapidly become eutrophic systems is very much associated with pollution, and that is a trend that we are seeing in many lakes in Florida, and something that lake managers are actually having to take care to limit and avoid if possible. Again, this system, this transition does happen naturally over hundreds of years. However, when it happens over 5 or 10 years very rapidly, that is when pollution is often suspected. And then finally, we're going to go over a few different types of freshwater ecosystems. So you're going to have wetlands. Wetlands are basically just terrestrial systems whose soils are basically permanently saturated with water, so that water table is going all the way up. And they generally feature shallow standing water as a general characteristic. They are enormously rich and incredibly biologically productive. Wetlands are some of the most biologically productive terrestrial systems on the planet, and they have enormous numbers of ecosystem services. They're extremely valuable as a habitat for wildlife. They reduce flooding, they reduce erosion by holding down the soil, and they do a fantastic job of filtering pollution. A lot of plants in wetland ecosystems are very good at pulling nutrients out of the water column, and so they do a great job of filtering pollution and reducing nitrogen and phosphorus from getting into more vulnerable systems. There are several different types of freshwater ecosystems, and particularly wetlands, that your book talks about. Freshwater marshes are very well known. Then you have bogs and swamps. Swamps are probably the most well-known of wetland ecosystem. And then you have something called vernal pools. We're not going to really get too much into the nitty-gritty as far as freshwater ecosystems. I'm far more interested in the ocean ecosystems and the coastal ecosystems. And that's something we're going to be talking about in the next lecture. So this is everything we have for the freshwater lecture of this chapter. I hope you guys have enjoyed it. I love the freshwater class. It is so cool to get to see all the features of the aquifers, as well as the different zones in a freshwater ecosystem, as well as the different nutrient and biological productivity states. I just think it's super cool. I hope you did too, and I can't wait to talk to you about my personal favorite lecture in the entire course. course, which is going over oceans and in particular ocean ecosystems. All right, I'll see you then.